This is 12.5, Rational Zeros Theorem with Sophie. Here's our equation, what we're going to start with. Okay, so the thing about rational zeros is that they are rational numbers. So let me show you what those look like. Rational numbers are anything from 1/2 to 0 to -1/2 to 100 to -100. So rational numbers exist on both sides of the realm. Okay. Next, we're going to be talking about irrational numbers, but that's in 12.6. Okay. So we have this problem down, and we can start the equation. Okay. So the formula that you want to use is P over Q, and what that stands for is the constant term. P equals constant, which is right here. That's your constant. Okay, so P equals constant, and this is your leading coefficient. Okay, so that's right here. This is your LC. Okay, so what we're going to do is we're going to do all the factors that make up the leading coefficient and your constant, okay? So that is +2 and -2, and +1 and -1, okay? Over +2 and -2 and +1 and -1, okay? So here we're going to make fractions out of each one of these numbers. So it's going to be all your possibles. Okay? So your possible rationals are going to be positive and -2. Okay? So do you see how that works? Is 2 over 1. Positive 2 or -2 over positive or -1 gives you positive or -2. Okay? And our next one is 1 over +1 or -1 over +2 or -2, which will give me positive or -1/2. Okay? And then next is positive or -1 over positive or -1. Okay? So that's positive or -1. Alright, and then 2, positive or -2 or positive or -2 also equals positive or -1. So we don't need to write that down twice. Okay? With that, these are going to be our dividing terms. So what we had during our last chapter, or our last section, which was 12.4, is with synthetic division. We had our dividing terms or our factors. So this is going to be, these are going to be all of our dividing terms, okay? So we're going to use synthetic division for this, and we can do that because we don't have any squares. Alright? And this is where you're going to come up with your real rational numbers. So rational, those are your real rational numbers, okay? So we're going to do exactly how we did in the beginning and with synthetic division, which is 2, +5, +1, and -2, okay? And what we're looking for this to be, for any one of these to be an actual rational, is for this to equal 0, so for it to completely even out and divide evenly, okay? So let's just start with 1/2, okay? So we have +1/2. I'm going to put that outside here. Alright, so if at the end it equals 0, then this will be one of our rationals. Alright, so first we drop down the 2. That's 2. 2 times 1/2 is 1. 5 plus 1 equals 6. 6 times 1/2 is 3. 3 plus 1 is 4. 4 times 1/2 gives me +2. So -2, -2 plus 2 gives me 0. So this is one of our rationals, okay? Right, so there's one of our rationals right there, and next all we have to do is all over again. But don't forget, in the end, we have to divide by 2, okay? X squared plus 3x plus 2. Right, so that's our initial equation. Next, we have, we can pick any one that we want, and there are 6 possible here, so don't forget that there are 6 possible here. Okay, so that's 1, 2, 3, 4, 5, 6. So we have 6 possible answers, and I think we're going to end up with 3. I'm not sure. Okay, so we have to do that all over again. It's 2, 5, 1, -1. Or, if something simpler is, instead of doing this all over again, we can factor this out, okay? So here, we're going to end up with an ACB table, B table, and whatever multiplies to 2 and adds to 3, that's going to be positive 2 and positive 1. So whenever I factor that out, that'll be x plus 2 and x plus 1. So we're going to set x equal to 0. Okay, and we're going to solve for x, so that'll give us x, x equals -2 and x equals -1. Okay, so those are our other 2 rationals, and that's the end of the problem. I'm going to take a minute to write that down, pull out another sheet of paper for our next problem, okay? So, with our next problem, we are going to have f of x equals -6x cubed, minus 49 x squared minus 18x plus 8. Okay? In the beginning, you do not want to find a common, a greatest common factor, because then that'll throw the whole problem off. Okay? So we're going to do p over q. This is our leading coefficient, is -6. Let's see, this is our constant. So our constant goes on top, and we are going to have a lot of possible rationals here, okay? So we'll just list all of our possibles. Alright, so with our possibles, we could have positive or -6, positive or -2, positive or -3, positive or -1. Okay, so that's just for the leading coefficient. That's just for this q part. Okay? With our constant, we can have positive or -8, positive or -4, positive or -2, and positive or -1. Alright? So this is our constant. So remember that we're going to have to do factors of each number, not just the number itself. So 2 times 3 gives me 6. Or -2 times -3 gives me positive 6. Or -2 times positive 3 gives me -6. So we have to do all the factors, all the possible factors. So that's a lot of possibles. So now we have to do p over q. So let's do 8 over 6. And we can reduce these later. Positive 8 over 6, positive or minus 8 over 6, positive or -4 over 2, positive or -2 over 3, positive -1, okay, positive or -8 over 2, positive or negative positive or -4 over 3, positive or -8 over 3, And the list goes on and on and on, okay? So we can simplify these right now. So our actual positives will be all these simplified terms right here. Right, so those turn out to be positive or negative 1, positive or negative 2, positive or negative 4, positive or negative 8, positive or negative 1/2, positive or negative 2/3, positive or negative 4/3, positive or negative 8/3, and positive or negative 1/6. Okay? So these are actually all of our possibles. Let's cross this out, because these are all the simplified, condensed down versions of it. So we have to test each and every single one of these to make sure that we get the right one. Okay? And there's no quick trick, there's no shortcut to finding out one. We're just gonna plug. Okay? I'm just gonna plug them in. So we set them up like synthetic division, and we're just gonna start with -1. So we have -6, -49, -18, and +8. Alright, so we bring down the 6 first, so that's -6. -1 times -6 gives me +6. That gives me -43. -1 times -43 gives me +43. And then -18 gives me positive 25 times -20 times -1 gives me -25. Okay, so whenever I add 8 to -25, it gives me 17, and that does not equal 0. Okay, so we have to plug in something else. We're gonna just try 2/3. I think -2/3. All right. So with that, I need to make sure we're doing synthetic correctly. -49, -18, and +8. Okay? So then we bring down our 6, our -6. -6 times -2/3, if we do this like this cancels out, that's 1. So it's -4. Just kidding, it's +4, which gives me -45. Then -45 times -2/3. Gives me +30. -18 gives me 12. 2/3, -2/3 times +12 gives me -8. So -8 does cancel out to 0, and then we have to simplify this. Okay? Once we simplify that, that gives me -2x squared minus 15x plus 4. And if we do our ACB table, there is no, this is unfactorable, okay? So it's just -2/3. So all of your rational numbers are -2/3. That's it, okay? Out of all of these rationals, this is the only one that actually worked. So it's just a matter of picking the right one and going with it. Okay, that's the end of 12.5. Thank you for watching.